Look at this edge. The water simply runs out of bounds and fuses with the sky. It feels completely effortless. But that peaceful surface hides a relentless physical reality. Thousands of pounds of heavy water are constantly throwing themselves over that wall, hour after hour. That water doesn't vanish. It is caught and pumped right back up. But think about the exact second the power goes out. That massive sheet of water is already falling. Where exactly does it all go? I'm Randy Beard. For decades, I've had to answer that specific question before moving a single shovel of dirt. If a designer ignores the fluid dynamics hiding just below the sightline, a beautiful architectural showpiece quickly turns into a very expensive flood. The low wall the water spills over is the weir, a surface precision engineered to dictate the exact behavior of the falling sheet. A crisp 90-degree knife edge peels water into a clean, detached sheet. Round that crest over, and surface tension makes the water slide quietly down the stone. Tilt the surface downhill, and the water fully commits to the drop without creeping backward. No matter which profile you choose, the entire length of that weir must be dead level. We are talking about tolerances measured in millimeters. This graphic demonstrates why those tolerances matter. If one end dips even slightly, every gallon in the pool will find it. A uniform sheet instantly collapses into a solitary trickle at the lowest point. Water is an uncompromising inspector. The flawless, glassy line you see from the deck is a direct reflection of the craftsmanship beneath it. All that falling water lands in a hidden tank, the catch basin. This trench acts as the critical shock absorber for the entire aquatic system. Its first job is crisis management. The moment the pump shuts off, the basin has to swallow all the water currently in the air, on the wall, and racing toward the edge. In the industry, we call this the water in transit. A quarter-inch of water stripped from the pool surface arrives all at once, forcing the basin's level to rise rapidly. When the system kicks back on, the basin must feed the intake pump without gulping air before balancing. It needs reserve volume for heavy winds, evaporation, or swimmers suddenly jumping in and pushing a massive wave over the edge. If you calculate this volume incorrectly and build the basin too small, a single momentary power flicker will send a destructive wave straight down your hillside. To avoid that risk, some builders overcompensate. They construct an enormous, obtrusive concrete trough right in the middle of the sightline, ruining the specific view the client paid to enjoy. The perfect catch basin relies on exact mathematical formulas executed in the blueprint stage. On these projects, luxury is a product of calculation. Looking at a finished pool, the water is calm. The system operates in total, quiet harmony. When the weir is level and the basin math is correct, the homeowner never has to think about a single drop of water. The highest level of structural engineering is the engineering that remains entirely invisible. Capturing the water is the first step. Next time, we look at the hydraulic muscle, the networks that move this volume in total silence. Building water that touches the sky requires a flawless hidden foundation. I'm Mandy Baird. Let's keep building.